also thinking.
We're going to end on these people tried to kill me. Okay. And we are starting my video with that. Okay. That was Italia.
Yeah, I was almost killed.
All right.
Oh my God, he's watching
Decimal equivalents. Hey, and remind me when we are done.
To clean out our folder.
Yeah, I have up there a clean folder. So when we're done with this, I definitely want y'all to clean out. Shh. If you haven't, go ahead and clean out all material except for 5.1, 5.2.
Right now?
No, when we're done.
Okay.
And same with science. You can clean out everything in science because today we start a new chapter. Yes?
I don't have a math folder. I have two folders that I use. A science folder for science, and then I have another folder for every other subject. So,
That ain't good.
I'm going to just get started. All right. Here we go. Shh, stop singing. All right, decimal equivalents. Yes, we're dealing with decimals. I'm not going to, there's a section of this concept that I'm not going to address. It's, and it's okay. It's okay. But everything else, yes, we're dealing with decimals. It's not going to be horrible. Some people are better at it than others. Decimals, when I was a kid, was not my thing. Okay, so I understand. That's why I'm going to make this as painlessly as possible. All right. If a decimal, can you imagine if I talk like that the whole time? If a decimal is a rational number, it will either terminate, I like that word, terminate, or repeat. All right. Terminator.
Oh, no.
Okay, so if a decimal is a rational number, okay, it will either terminate, that means like 5.3, and that's it. Or it's going to repeat, like 5.333333333.
so like, am I going like the line above it?
Bingo, that's what we're doing today.
Okay.
But if it never stops, it just keeps going and going and going and going and going, it is not a rational number. If the numbers are all different and there's nothing repeating, it is not a rational number. The only time a decimal is a rational number, it's going to either terminate, means it stops, it's done. There's nothing after it. Or it's going to be repeating, like 5.333, with the line over it. It can even be 0.635.
Do we write this?
Yeah, you can. And that's repeating. You know what I'm saying?
What the only time
That would look like this.
Yeah. The only time a decimal is a rational number is what?
Okay, look. Do you see how it's not just 33333? Do you see that 635, 635, 635? So then 635 is what's repeating.
Okay, but you said that if it never ends, it's not rational.
Okay, so if it never ends, it's not rational. If it ends or is repeating, which is this, then it is rational.
Oh, so you're not saying if it's like just continuously 3. You're saying if it just...
Okay, for example, I see what y'all are saying. So this is an example of a weird repeat. And yes, it could be like that. It's not always going to be little pretty things like 5.3 repeating. Okay? It could be 3 numbers that are repeating. It could be 5 numbers that are repeating. You see what I'm saying there? Do you not, Atalia?
I know I do.
Oh, you're just like, oh my word. Okay, I gotcha. Now, where it says if it is not a rational number, it would look something like this. Yeah, 3, 2, 5, 6, 9, 7, 8, 0, 5, 2, 4. Yeah,
Will there
okay.
be a point to where we have to like?
Now, hold on. This, not rational. That makes sense. It's not rational to me.
What if it were like? What if we got to that number and then it started repeating that whole time?
It can happen. It can
We'll have to solve
absolutely
it like
happen.
that?
No. You guys, in pre-algebra and algebra 1 will never have to do that, okay? You will not have that. It's gonna be something you can handle, okay? But yes, there's always a possibility that there's like 8 numbers and then it starts over and repeats. It's math, but you will not have to deal with that. But just know that it can happen. Does that make sense? All right. Any questions so far? Are you taking notes? Okay. Do we all understand the difference between a rational decimal and a not rational, irrational decimal?
Yes.
Okay. Do you, Kelly?
Kind of.
Which do you not understand? Because I don't want to move forward until you do.
Well, why would the number start repeating?
It just, you'll see when we do examples, sometimes you're working something like this out. Okay, and you're working it, you're doing the division, and it starts doing this. And you're like,
It's division.
it's when we're dividing.
Okay,
Thank
I
you,
understand.
Natalia. That makes more sense. And so you're sitting here dividing, and you're like, wait, I keep getting 3 over and over again, so therefore 3 is repeating. If you were dividing here, and you could stop right here and say, oh, look, that's not a rational number. But you have to keep going. Oh, look, now I'm getting a 6. Oh, look, I'm getting a 3. Oh, I see a pattern here. It's repeating. 6, 3, 5 is repeating. Yes, ma'am.
What number do you usually like end? Like stop.
Like what place? That's hard to judge because there's really no set place unless your book or the directions say stop at the thousands place or something like that.
Oh.
Thousands,
Yeah,
tenths,
yeah.
hundreds, that's not too far.
I was like, what?
But because of this, in fact, one of the problems, I was going over the problems, yesterday, like I do. One of the problems actually had like 4 numbers before it started repeating. Okay, so you kind of have to go to the 4th or 5th place to see if it's repeating. You will know. Most of your homework, I think, is only either 2 numbers repeating or 3 numbers repeating or something. I don't think there was 1, but I don't know if I even assigned it. Yes, ma'am.
So what if it were to be like 0.423, 425, 42, and it's just repeating the 42, but there's a different number after it?
Okay, what she's saying, y'all do not need to write this down. So 0.425436489 like that, right? Okay, so
like where it's, or I mean that's the same thing. Like where it has like 425, 426, 429, 429.
okay, but because so she's saying there's a 2 here and then like a 2 here. So the 42 is repeating, but we have this 5 here and this 6 here and this 9 here. So therefore nothing's repeating. It has to be consistent, like 635, 635, 635, or 33333.
So the numbers have to be the same.
They have to be the same. There can't be any weird break in between. Does that answer? Okay, good. So any other questions? Joseph, are you seriously making an airplane while I'm teaching? My word. Okay.
It's not in there. It's like a little hut.
I know, it's kind of cute actually. Okay. So, any questions before I move on? Okay, good.
Wait, just sorry.
That's fine.
Just clarifying, rational numbers is when it's repeating.
Rational if it repeats, like we did these examples, or if it terminates.
What's terminate mean?
Like if you're doing the division and you stop at 3. Like if you're doing a division problem and it's 4.3, no remainder. There's your answer. That means terminate. Like you don't continue going on and on and on. Any other questions? All right. Okay, so now that we have that, we are going to convert a fraction to a decimal. We're going to convert, that's a colon. We're going to convert a fraction to a decimal. So we're going from fraction to decimal. And yes, I put that arrow there because when you look back in your notes, you want to make sure.
You don't need decimal fraction.
Yeah, exactly. Okay. So when you're converting a fraction to a decimal, you're going to divide the numerator by the denominator. All right, now ready? So we've got 3 over 4. We're going to convert that to a decimal. We do that by dividing the numerator by the denominator. So,
I have a question.
yes.
Before, so what if it can go in evenly?
Well, then it's not going to be a decimal. It's going to be just a whole number.
Which,
So-
if it's a whole number, is irrational.
Well, yeah. So the horse goes on the outside of the house. The cowboy goes inside. Yes, Natalia. Oh, okay. So can 4 go into 3?
No.
So then we're going to put a decimal here, a decimal on top, and add a 0. You need to make sure that you put your decimal on top. And if you get confused, like when I said, does 4 go into 3, and she said no, you can put a placeholder 0. Actually, if you look, that's what you should do. Okay, so now, Natalia, how many times 4 go into 30?
8 times. No, sorry. 7 times.
7 times. 7 times 4 is?
28.
And we subtract. 30 minus 28 is?
2.
All right, so we have a remainder, but we're doing decimals, so we don't have a remainder. We keep adding zeros. How many times 4 go in 20?
Times.
And I'm putting it right over the digits. 5 times 4 is 20. You subtract, okay. We've terminated. We've gotten to a remainder of 0, so that's where you stop. So your answer is 0.75. That's how you change a fraction to a decimal. Any questions? Yes, ma'am?
Can't we just, like, if we do know what 3/4 is, can't we just write it as a decimal instead of solving it out?
Yes, but this is if you don't know.
Because, like,
Okay,
3/4.
so for example, 5 over 12. Do you know that by heart? Okay. Most of the time, you're not going to know what the decimal is. So, Tanner, how do I solve this?
5 on the inside, 12 on the outside.
That's right. The horse goes outside.
So, probably with the decimals, the lower number, smaller number will go on the inside.
Not always.
If it's
Just remember, cowboy is riding the horse. You never put the horse in the house.
Okay.
You put the cowboy in the house. The horse gets tied up outside in the rain. Okay. So can 12 go into 5?
No.
I'm going to put a 0 right over that 5 then. And what do I need to add?
0.0.
A decimal, and I put it there and right above. And yes, ma'am, a 0. So, Tanner, do you know approximately how many times 12 can go into 50?
4 times.
Perfect. And you can always off to the side check 12 times 4 to see.
I thought it.
So 4 times 2 is 8.
And that's 28. Oh no, that's
4, look, 4 times 2 is 8, and then 4 times 1 is,
4.
there you go. 50 minus 48 is 2. I'm just helping you out here.
Okay.
So, oh my goodness, we haven't terminated yet. So what do I need to do now?
0.
Add a 0, bring it down. How many times?
1 time.
There you go, 1 time. 1 times 12 is 12. 20 minus 12 is 8. What do I do now? Because I haven't terminated.
0. Bring down 0. I'll try to do this one.
Okay.
Okay,
Well, we know, look here, look. We know that 4, if it goes in there 4 times, we get 48. And we're trying to get to 80.
so it's, I know it's, probably 7.
Try it.
No, okay, it's 6, 72.
There you go. Good job, Tanner. So 6 times 12. And since you did that work on the side, don't cross it out when you're done because you may need it again. So she already knows 6 times 12 is 72. So we subtract and we get 8. Now what do I do?
0.
So we got to keep going. Oh my, look at this. 12 goes into 80
72.
6 times. Okay, do you see what's happening here? What's happening?
Repeating.
That's right, because if I added another 0 right down, we're still 80, 80, 80. So your answer is 0.4. What is repeating?
6.
Just the 6, guys. Do y'all see that? The 4 and 1 aren't, just the 6. So I'm going to write the 4 and the 1 there, and then I'm going to put the 6 there with a line over it.
I have an idea on how we could remember that, like, so basically the end number is, if it's a singular number that's repeating, that's the only number that
Yeah, right.
we put a line over.
Now, notice, the line is only over the 6. If I put the line over the 4 and the 1 as well, that's saying the 416 is repeating. So that would be wrong. Does everyone see that? The line only goes over it. Kelly, do you see that? The number that's repeating, not the whole thing. Got it? All right, any questions? Okay. Now, we're going to convert, because I think you got that down, a decimal to a fraction. So we're going from a decimal this time to a fraction. All right, y'all ready?
Yes.
This one takes a few more brain cells. All right, so let's say we have the number 0.175. Write that down. Step 1. Find what place value the last digit sits.
Oh, it's like tenths, hundredths, thousandths.
I
Exact-
forgot what the place value.
Well, you're going to have to remind yourself.
It goes from. So you
Well, as soon as you get that down, we'll talk about this. You'll remember it. Okay, so what's the last digit, Kelly?
5.
That's right. So that's what step 1 says. Find what place value the last digit sits. What place is the 1? Atalia?
tenths,
7.
hundredths, thousands.
Okay. So 5 sits in thousandths place. 5 sits in thousandths place. This is going to be your denominator. Step 2, the place value becomes the denominator. So 5, it's always the last digit, guys. Always the last digit. Do you understand that? Last digit.
What if it's an infinity?
It's not going to. You can't change that. Then you can't convert it.
Oh, it's decimal.
So the last digit's in thousandths place. That 5 is in the thousandths place. That's going to become your denominator. So step 3, make the numerator the decimal without the decimal, the decimal number. I'll show you. Okay, so what place is the 5 in?
Thousands.
So it's the denominator, right? So I'm going to put 1,000 there because that's the place. Do y'all all see that?
But wouldn't it be blank?
The 5 is in the thousandths place. That becomes the denominator. So the denominator is 1,000. Step 3, make the numerator the decimal without the decimal. Here's your decimal number. Here's your decimal number. We're going to get rid of that. It's 175.
Wouldn't the denominator be 5,000?
Nope. It's just whatever place it's in. It's in the thousandths place, so we put 1,000. Good question. Do you see that? Talia, do you see this? So you're just removing the decimal, putting that number on top, and the thousands because the 5 is in the thousandths place. Now we reduce. Let's divide both sides by 5 because 5 can go in there. 175 divided by 5 is 35. 1,000 divided by 5 is 200. Is it in lowest terms?
Nope.
We can divide again by 5. 35 divided by 5 is 7. 200 divided by 5 is 40. That is in lowest terms, and there's your answer. See? A little more brain cells. Any questions? Be glad I'm not talking about converting repeating decimals.
Oh.
Thank you.
We're going to go with this. Any questions? All right. Let's see. Let's go ahead and get started on examples. Y'all ready? Turn to page 197. Y'all ready? Are your books open? To the right page? All right, here we go. Number 2, Joseph, please read the directions.
Convert the following fractions to decimals.
All right, so we're going from fractions to decimals. 1/20. So, Joseph taught me through how do I turn this fraction into a decimal.
So the 1 needs to go inside the box, and the 20 outside?
All right, so does 20 go into 1?
No.
Now what do I do?
Put the decimal.
And add a,
0.
can 20 go into 10?
No.
So what do I do?
Add another 0.
Can 20 go into 100?
Yes.
How many times?
5.
5 times 20 is 100. No remainder. It terminates, so we're done. So what is your answer?
0.05.
Any questions? Yes?
Wouldn't you also pronounce it 0.5?
No. 0.5 looks like this. 0.05 looks like this. This is in tens place. That's hundreds. 2 totally different numbers.
Or you could say like 500.
5 hundreds, yes.
And also, if it were 0.5, it would have to be 10 over 20 because half.
Okay. Any questions? Let's do another. 4. Italia. 3/8. Tell me what to do.
So 3 goes on the inside, 8 goes on the outside.
Can 8 go into 3?
No.
Add a decimal, right? And
A 0.
can 8 go into 30?
Yeah.
How many times?
3.
3 times 8?
24.
30 minus 24?
6.
Oh dear, I have a remainder. What do I do now?
Add another 0.
Can 8 go into 60?
Yeah.
How many times? 7 times 8?
56.
Gives me 4. I'm still going.
You add another 0. Gives me 5 times. And you have no remainder, so.
I terminate.
So
Okay.
0.375.
Very good. Any questions? Do we understand how to do this?
Yes, ma'am.
All right, let's look at number 10. Let's see. Tanner, read the directions.
Convert the following decimals to fractions or mixed numbers in lowest terms.
All right, so 10 is 0.625. So, what's the first thing we do, Tanner? Look at
Place value
of which number?
5
And 5 is in what place?
thousands.
So the denominator is 1,000. what do I put as a numerator?
625
Excellent.
time.
625 goes on top. Now, if we reduce it and to save on time, I'm going to go ahead and just tell you, if you reduce this enough times, I'm going to put lowest terms. And y'all know how to do that, you would eventually get 5 over 8. Because y'all know how to do lowest terms, right?
You divide until you
Until you
Don't
get,
have any
till you
common
can't divide
factors.
anymore. Any questions about that? All right, let's look at 12. Kelly, negative 0.8. What's the first thing I do, Kelly?
I'm gonna read the directions again.
We're converting this to a fraction.
We're converting that to a fraction.
Yes.
So then the 8 is oh wait, never mind. So it's in the tenths.
That's right. The 8 is in the tens place. This is a negative. The fraction's going to be a negative. 8 is in the tens place, so I have the denominator as 10. What do I put on top?
Negative 0.8.
No. Look at what Tanner did.
8.
That's right. No decimal. And then we reduce it, and you get negative 4 over 5. Does everyone understand?
And the negative is referring to the entire fraction.
Yep. All right, look at 14. It's weird.
Can I do it?
I have a whole number 2, 0.55.
So you look at the last digit, which is in the hundredth place.
That's right. That's tenths and hundredths. So therefore, 100 is on the denominator, or in the denominator.
So then you would take away the decimal and you'd put 225. 255.
Actually, you could bring that 2 over, and it can stay a whole number. So then what would we put on top? Just 55. Notice that, guys. The 2 just brought over as a whole number.
It's the same thing though, isn't it?
It will be eventually. 55 just goes over 100. We reduce that, and you get 2 and 11 over 20. You just reduce that fraction. That would be divided by 5, and that would be divided by 5. Does everyone understand how to handle whole numbers? All right. You understand how to do repeating numbers and everything? Y'all ready? I won't give y'all much. Page 197. Numbers. Five to 25 odd. That's 11 problems. That's due Monday. Your quiz, I moved to Tuesday. Okie dokie? I know you are tired.